most people hear the word aviation, they think of airlines, large jets, international terminals, commercial travel. But in the United States, most aircraft are not airlines. They are general aviation, and general aviation is not a niche sector. It is the structural foundation of the American aviation system. In 2023, the active U.S. general aviation fleet consisted of approximately 214,000 aircraft. That number represents aircraft that actually flew at least 1 hour during the year. At the same time, there were over 20,000 aviation landing facilities in the United States, airports, heliports, and seaplane bases combined. To put that into perspective, scheduled airlines serve fewer than 500 airports nationwide. General aviation serves thousands of communities that would otherwise have no direct access to the national airspace system. So, what exactly is general aviation? From a safety and regulatory standpoint, general aviation includes all civil aviation operations not conducted under Part 121 or Part 135. Part 121 governs scheduled airline service. Part 135 governs commuter and on-demand commercial operations. Everything else, primarily operations conducted under Part 91, falls under the general aviation umbrella. That includes private and recreational flying, flight instruction, corporate aviation under Part 91, agricultural operations, medical air transport, aerial survey and firefighting, experimental aircraft testing. This distinction matters because regulatory structure directly influences operational environment, training requirements, and oversight intensity. Now let's examine the fleet itself. General aviation in the United States is overwhelmingly piston dominant. Approximately 2/3 of the active fleet consists of piston-powered airplanes. Experimental aircraft account for nearly 1/5 of the fleet. Jets and turboprops represent a much smaller share numerically, roughly 10% combined. But they generate a disproportionate share of economic output and business mobility. Rotorcraft account for roughly 6% of the fleet. What this tells us is that general aviation is not one operational environment. A student pilot in a 1970s Cessna 172, a corporate flight department operating a Gulfstream, a helicopter air ambulance crew launching at night, an experimental builder conducting a first test flight. All of these operations fall under the same broad category. That diversity is both a strength and a challenge. Now consider the human side of the system. There are more than 800,000 active pilot certificates in the United States. The student pilot population has increased significantly over the past decade, reflecting renewed expansion in the pilot pipeline. General aviation is not simply recreational. It is the primary training ecosystem for commercial aviation. It is the distributed infrastructure that supports rural connectivity. It is the testbed for emerging technologies. And it contributes nearly $180 billion annually to the U.S. economy. But scale and diversity introduce complexity, and complexity introduces operational risk. Understanding general aviation requires more than knowing how many aircraft exist. It requires understanding how those aircraft operate, under what regulatory structure, with what level of oversight, and under what economic pressures. In the next section, we will examine how safety performance in general aviation has evolved over the last decade, and why its risk profile looks fundamentally different from the airline world. In the previous section, we established something important. General aviation is large, it is decentralized, and it operates primarily under Part 91, often single pilot, without the institutional structure of airlines. Now let's examine how that translates into safety performance. On your screen, you see the safety trend data from 2014 to 2023. Focus first on the total accident rate per 100,000 flight hours. In 2014, the total accident rate was just over 5 accidents per 100,000 hours, approximately 5.08. As you follow the line across the decade, notice the gradual downward movement. There are small fluctuations, slight increases around 2016 and 2019, but the overall trajectory trends downward. By 2023, the total accident rate decreases to approximately 3.86 per 100,000 flight hours. That is a meaningful reduction over 10 years. Now look at the fatal accident rate beneath it. In 2014, The fatal accident rate was close to 1 per 100,000 flight hours, about 0.98. Across the decade, it declines with some variation, but the trend is clearly downward. By 2023, it reaches approximately 0.65. That represents significant improvement in fatal risk exposure, so the data shows progress. But progress must be interpreted carefully. Now compare this to Part 121 airline operations. Major U.S. airlines routinely operate with fatal accident rates that approach zero in most years. That difference is not simply a matter of pilot skill. It reflects structural differences in the operational system. Airlines operate within layered safety defenses, dispatch oversight, 2 pilot crews, mandatory recurrent simulator training, flight data monitoring programs, centralized operational control, highly standardized procedures. General Aviation operates differently. Most GA flights are single pilot. There is no dispatcher reviewing your weather. There's no operations center monitoring fuel reserves. There's no required flight data monitoring in most piston aircraft. And training frequency varies widely across the pilot population. Now connect this back to fleet composition. In the previous section, we saw that approximately 140,000 of the 214,000 active GA aircraft are piston-powered airplanes. That means the majority of flight exposure occurs in small, single-engine aircraft, typically under Part 91, often flown by owner-operators. That exposure profile shapes accident patterns. When we analyze NTSB causal data over the past decade, one category consistently leads fatal accidents in general aviation: loss of control in flight. These events often occur during maneuvering, stall spin scenarios, or transitions in energy management. Weather-related accidents, particularly VFR flight into IMC, remain persistent contributors. Controlled flight into terrain continues to appear in night and low-visibility environments. Fuel mismanagement accidents, though less common than decades ago, still occur. Notice something critical. Most of these accidents do not begin with mechanical failure. They begin with a decision chain. An airspeed margin reduced, a weather assumption extended, a proficiency gap exposed. General aviation risk is often cognitive and procedural, not structural redundancy failure. The downward trend in accident rates tells us safety initiatives, training improvements, and avionics modernization are having measurable impact. But the plateau behavior in some years also reminds us that decentralized systems improve differently than centralized ones. General aviation is not the airline system at smaller scale. It is a fundamentally different operational ecosystem. Understanding that distinction is essential before we discuss its strategic importance and future direction. In the final section, we will examine why general aviation remains critical to national infrastructure and how its safety evolution must continue to adapt to technological and operational change. We've examined the structure of general aviation. We've examined its safety trends. Now we need to ask a different question. Why does general aviation matter? In the United States, there are roughly 5,000 public-use airports. Scheduled airlines serve fewer than 500 of them. That means general aviation connects thousands of communities that would otherwise have no direct access to the national airspace system. Most of these airports are non-towered. They support medical flights, agricultural operations, firefighting missions, law enforcement aviation, business travel, and flight training. General aviation is not peripheral infrastructure. It is distributed national access. Now consider the economic dimension. General aviation contributes approximately $180 billion annually to the U.S. economy and supports more than 1 million jobs. Business aviation increases productivity and regional competitiveness, and every airline pilot in the United States begins in general aviation. It is the national pilot production system. If we had to summarize its structural importance, it rests on 3 pillars: infrastructure access, economic mobility, pilot development. But the future introduces pressure. The piston fleet is aging. The pilot population is aging. Insurance costs are rising. Training expenses continue to increase. At the same time, avionics modernization, ADS-B integration, and emerging advanced air mobility platforms are reshaping the operational environment. So the strategic challenge is clear. General aviation must evolve. Its future safety performance depends on data-driven decision-making, technology integration, training modernization. General aviation is not the shadow of the airlines. It is the foundation of American aviation, and how we manage its evolution will shape the safety and accessibility of the entire system.